In this video, we're going to talk about multiple integration, double and triple integrals. I have an integral here to evaluate. It's a double integral. This integral is actually in two parts. I'll first of all evaluate this one that is inside. That's this function with respect to x from 2 to 5. Let's do that first. This is the integral from 1 to 6. Alright. If I integrate x squared with respect to x, that will be x cubed all over 3. By the rule of integration, you add 1 to the power and divide by the sum of that power. And if I integrate 4y with respect to x, that will be 4yx or 4xy. How is this so? Since the integration is with respect to x, we'll take all other variables as constant. We'll take y as a constant. You know, if we integrate a constant, let's say 2, we are going to obtain, if I integrate 2 with respect to x, I'll obtain 2x, neglecting the constant of integration. If I integrate x with respect to k, I'll get sk. That's it. So if I integrate 4y with respect to x, 4y will be a single constant to multiply x, and that will be 4yx. From 2 to 5 dy. So we now substitute the upper and the lower limits. We have the integral from 1 to 6 of plugging 5 for x first. That's 5 cubed all over 3 plus 4 will enter here, that's 20. Because 4 times 5 is 20, so we have 20y minus 2 will enter, that's 8 all over 3 plus 8y, because 4 times 2 is 8 dy. 5 to the power of 3 is 5 times 5 times 5, and that's 125. So we have 125 over 3. Then plus 20y minus 8 over 3 plus, okay, this is minus 8y dy. And what would this be? The integral from 1 to 6. 125 over 3 minus 8 over 3 is this. 125 divided 3 minus 8 over 3. 8 divided 3. That's 39. Okay, 39. So this minus this is 39. 20 minus 8 is 12. So we have plus 12y dy. So we now integrate this with respect to y. We have the integral from, okay, we now have this. Integrate 39 with respect to y, that's 39y, plus integrate 12y with respect to y, that will be 12y squared all over 2. We added 1 to the power and divide by that sum 2. From 1 to 6. Okay, this is actually 39y plus 6y squared, because 12 over 2 is 6. So plug in from 1 to 6. We now plug in the upper limit. That will be 39 times 6 plus 6 times 6 squared minus, we plug in the lower limit, 1. 39 times 1 plus 6 times 1 all squared. 39 times 6 is 234. 234. Okay, let's add it to this. Okay, this is 234. This is actually 6 raised to the power 3. 6 to the power of 3. 216. Okay, that's 216. Minus is 39 plus 6. 234 plus 216 is 450. So we have 450 minus 39 plus 6 is 45. and this will give us 405. So this is the value of the double integral. Look at this. First of all, we take this integral. The integral from 1 to 3 dx. If we integrate this with respect to y, we'll get this. Integrate 40 with respect to y, that's 40y. We're integrating minus 2xy with respect to y. Minus 2x is a constant, and if we integrate y, we are going to obtain y squared all over 2 from 2 to 4. That's the limit of integration. Okay, so this is the integral from 1 to 3 dx into, we plug in the upper limit and then the lower limit. 2 cancel 2. Plug in 4 here, that's 160. Plug in 4 here, that's 16. 4 squared is 16, right? 16 times x, that's 16x. Minus, plug in 2 here, that's 80. Then if we plug in 2 here, that's 4. 4 times x, that's 4x. So we say this is the integral from 1 to 3 dx into 160 minus 80 is 80. Minus 16, this is plus. Minus is a plus. Minus 16 plus 4 is minus 12. And this is the same thing as saying the integral from 1 to 3 of 80 minus 12x dx. See, they are the same thing. So we now integrate this with respect to x. So integrate 80 with respect to x, that's 80x. And if we integrate this with respect to x, we have minus 12x squared all over 2 from 1 to 3. And that will be 80x minus 6x squared from 1 to 3. Plug in the upper limit, that will be 80 times 3 as 240. Minus this, plug in 3 here, that's 9. Okay. 3 here is 9 because 3 squared is 9. 9 times 6 is 54. Minus, we plug in the lower limit. 1 times 80 is 80. 1 squared is 1 times 6 is 6. Okay, let's evaluate this. This is actually the same thing as saying 240 minus 54 minus 80 plus 6. 240 minus 54 minus 80 plus 6. 112. That's the integral. That's the value of the integral, the double integral. Consider this triple integral. Okay, we're integrating with respect to x, theta, and phi. Let's go. We take the first one, the integral of x squared sine theta ds from 0 to r. So we have the integral from 0 to pi, from 0 to pi over 2 again. Since we are integrating with respect to x, then sine theta will be a constant. So I'll have integrate x squared with respect to x, that's s cubed all over 3. So we're having s cubed all over 3 times the sine theta is a constant from 0 to r. Then I'm writing the theta d phi, the theta d phi. So if I evaluate this, I'll be having the integral from 0 to pi, the integral from 0 to pi over 2. Plug in the upper limit, which is arrow, we're having arrow cubes all over 3 sine theta, minus plug in the lower limit, which is 0. If I plug in 0 for x here, everything here becomes 0. So there's no need for that. The theta d phi. So I'll now integrate this I'll take the second integral now, this one, with respect to theta. It means that we'll take arrow as a constant, right? So this is the integral from 0 to pi into arrow cube over 3 is already a constant. Remember, the derivative of sine theta is cos theta. So the integral of sine theta is minus cos theta from 0 to pi over 2. Okay, we have the theta. Okay, it's now the phi. We plug in the upper limit for theta. We have the integral from 0 to pi. Okay, minus arrow cube all over 3. We take it as a constant. Then plug in pi over 2, which is 90. Cos 90. Then we'll now plug in 0. Cos 0. The phi. Cos 90 is 0. Cos 0 is 1. So 0 minus 1 is minus 1. Minus 1 times minus arrow cube over 3 is positive arrow cube all over 3 d phi. Since it's a constant, we'll just say arrow cube over 3 phi. That's phi arrow cube over 3 from 0 to pi. We plug in pi for phi, it will be pi arrow cube over 3 minus, if we plug in 0 for phi, it will be 0, everything. So what's left? Pi arrow cubed all over 3. This is it for double and triple integration. Keep watching, subscribe to this channel, like this video, and share the video with your friends and your classmates. I'll see you in the next one.